right, guys, so we're going to get started with this here. So the first thing we're going to talk about today is the fundamental theorem of algebra. So we're going to talk about the fundamental theorem of algebra. Now, the first thing we're looking at is this here. This chart here is on your notes. And we look at this here. So the first one's a linear equation, 2x minus 1 equals 0. And the degree for this here would be 1, because the biggest exponent is 1. The degree is the biggest exponent attached to a variable. And the solution, if we solve for it, it would be 1/2. And the numbers of solutions that we would have would be 1. So the degree is 1, the number of solutions is 1. Well, when the degree is 2, the number of solutions we have is 2. When the degree is 3, it works out the number of solutions is 3. And even if, in the bottom one, even if we have repeated solutions, so -1 shows up twice, we still have 3 solutions. And that's really what the fundamental theorem of algebra is. And if we look at this here, it's really in the corollary. For a polynomial that has a degree n, then the equation has exactly n solutions. So whatever the degree of the polynomial is, tells me how many solutions the polynomial function should have. So if it's a cubic, if it's a degree 3, it will have how many? 3 solutions. It'll have 3 values that will make the function 0. Now, it's not saying that they're all going to be real solutions, but we should have 3. Okay, well, let's look at this first one here. Yes? Yes? Mm-hmm. So, looking at this first problem here, how many solutions does the following polynomial function have? How many solutions does x cubed plus 3x squared plus 16x plus 48 have? It would be 3, because the degree is 3. That's it. Now, the actual zeros would be -3, 4i, and -4i. Those would be the zeros, but this has 3 solutions. So any questions on this here? How many solutions does this one have? Should be. It'd be 4 solutions, because the degree of this polynomial function is 4. Now, the actual solutions for this here would be -2, -2, -2, and 0. So again, anytime we have repeated zeros, we count them more than once. Yes?
So it says how many zeros is the function?
Yep. Yeah, so the solutions, when we find a solution, we're trying to find out what value of x is going to make the function equal 0, yes? So we call them the real zeros, or the rational zeros. What's going to make it equal 0? Does that make sense? So a lot of times we have multiple different ways to say that, because we're looking at the zeros, the real zeros, the factors. There's a factor makes the function equal 0. Rational expressions, it's more than one way. X-intercepts. These are all different ways to say the same thing. It's just how we are approaching it. Questions on this here so far? We liking this here so far? All right, how many solutions does this one have? This one would have 3. How many solutions would this one have? 5. So the answer to this one would be 5, yes? It does have 5 solutions. Find all the zeros. So the wording changed. So now it's not asking us to actually say how many there are. It's wanting us to find them. It's wanting us to find them. Now at this point here, it's just saying find all the zeros. We don't have to list the rational zeros if we don't want to. And if I look at this here, would the rational zeros be fractions? Would we have a possible fractional rational solution? Well, no, because when we got fractional solutions, because again, all the possible rational numbers come in the form of plus or minus p over q. Q is the factors of what? The leading coefficient, yes? So if there were going to be possible fractional solutions, zeros for this here, I would need a q value different than 1. Because that's the only way we can possibly get fractional rational solutions. And that's only talking about the rational. So our complex and our irrational can still be fractions. Our rational most likely is not. So what we can do is, well, what would y'all do? What would be the first thing we can do to start trying to find solutions for this here? Graph it. Let's graph it in the graphing calculator. So to start off, we would hit y equals. We have x. Oh, I see what I'm doing. X to the 5th plus x to the 3rd minus 2x squared minus 12x minus 8. All right, minus 2x squared minus 12x minus 8. And when you graphed it, we got something like this here, yes? So how many solutions did we say this had? 5, yes? It's going to have 5 possible rational solutions, or 5 possible solutions, because the degree is 5, yes? Well, how many did we find for sure? 2, because we have one at -1, and I have one at 2, yes? So we'll start off with those there, but keep in mind that at -1, it doesn't really cross at -1, does it? It goes up, touches the graph. And even if we look at the table, we can see for sure that it does have a 0 at -1. So that'll come back into play here in a little bit. So the next thing I would do would be synthetic division. And I'll start off with -1. And when we do this here, we'll have 1 for x to the 5th. And since I don't have an x to the 4th, I'm going to put it as 0. We're going to have 1 for x cubed, -2 for x squared, -12 for x, and -8. Drop the first term. Any questions on this here? Now doing this here, you can really do these in the calculator. I've never brought this up too much, but this here in the calculator isn't that bad, because you'll have to still write it down. But what's our first step? It's -1 times 1, yes? So if I type that in, I do -1 times 1. Then I would hit plus the number on top, which is 0, yes? So -1 plus 0 would be -1. Then you just hit times -1, which would give us 1. Plus 1 would give me times negative 1, which would be negative 2 plus negative 2. And you're really utilizing the ANS, the previous answer, because it'll generate that for you. So you're really just repeating this process. Negative 1 times negative 4 is 4. Negative 12 plus 4 is negative 8. And negative 1 times negative 8 is 8. So we get 0, yes? That's what we wanted. Now I mentioned this earlier in this chapter where I talked about the fact that if a graph touches the x-axis, it has an even multiplicity. Y'all kind of remember that vaguely? Even multiplicity. If a graph of a function touches the x-axis but doesn't cross it, it has an even multiplicity, which means that the number of zeros at that spot is an even number of times. So where we saw that it hit the x-axis at negative 1 but didn't cross, there could be 2, 4, 6, 8, 10 going on. There's an even number of them there. So what that means we can try is we can try negative 1 again. Well, negative 1 times 1 is negative 1. Negative 1 plus negative 1 is negative 2. Negative 1 times negative 2 is 2. 2 plus 2 is 4. Negative 1 times 4 is negative 4. And negative 4 plus negative 4 would give me and negative 1 times negative 8 would give us positive 8. And negative 8 plus 8 gives us 0. Now there is a chance that negative 1, if it could work again, but if it works again, it has to do it twice, because we have to do it in pairs of 2. It has to have an even number of them. But the other spot we had was 2, wasn't it? So let's try 2. Because at this point, after I do it this time with 2, after we do this third synthetic division, what will the degree of this polynomial be? Because it started out at 5, yes? And each time we do this, it's decreasing the degree by what? 1. So I've done it once, so it went from 5 to 4. We did it a second time, it went from 4 to 3. If I do it again, it's going to go from 3 to 2. At degree 2, we know multiple ways to solve it, yes? So let's just do that, because if I can get it to a quadratic, I don't have to worry about trying multiple numbers. Well, 1 times, or 2 is 2. Negative 2 plus 2 is 2 times 0 is 0. 0 plus 4 is 4, and 2 times 4 is 8. So we get this here. So let's put the variables back in. Before we do that, are there any questions on what we've done so far? This is pretty much the same thing we've been doing the last 3 days. Yes? So when we put the variables back in, this will be our remainder. 4 is our constant term. 0 is the term with x, and 1 is the term with x squared. So what I'm left with is x squared plus 4 is equal to 0. Now, yesterday when we came across one like this, we had one similar to this, yes? We used the quadratic formula, yes? We have a different method for it. You all remember the square root method? If there's not a middle term, we get x squared by itself and square root both sides, yes? And anytime I get that, and I don't have a middle term and it's a quadratic, that is what I'm going to go to first. Because if you remember with the quadratic formula, we spent multiple times doing that. And they're stapling the wall. How's that sound? So what we're going to do here is we're going to subtract 4 from both sides. Because 4 minus 4 is going to give us 0. So x squared is equal to negative 4. And we would square root both sides. And it tells me that x is equal to, because square root of x squared, the squares cancel, plus or minus 2i, yes. Because the negative is going to come out as I, and the square root of 4 is 2. Questions on this here? Let's see here. Yep. Oh, there it is. Issue. So this here is two solutions, yes? Because we have the positive 2i and the negative. But what were our other solutions? Because we had x is equal to negative 1 as well as negative 1 and 2. How many solutions do I have here? 5. How many were we supposed to have? We have all 5. So we're done. So we got negative 1 twice. Yeah, because 2 only showed up once.
So we just,
Yeah. If it really, well, if the calculator, because yesterday when we used the calculator, how it gave us 3 for that 1 cubic. Well, it's a cubic, so it should have 3, yes? It gave us all 3. We're done. If the calculator gives us every single answer, like on a cubic, degree 3, and it gives us 3 answers, we have them all, don't we? So we're done. Yesterday, we had to go through and use the synthetic division because we didn't, at that point, have a way to say that these were all the solutions. Now we do. So if it turns out that every single one of the solution shows up, that's all we have to do. Let's look at this next one. So this one here is a cubic, so we should have 3 solutions, yes? So let's look in the calculator. Let's graph this, because if I graph this, and I'm given 3 solutions, I am finished. Because that's all we need. We only need 3 solutions. So we can go y equals x to the 3 plus 7x squared plus 16x plus 12. So looking at this here, what solutions did the calculator tell us? So it gave us 2, yes? 2 for sure. It actually gave us 3, but it gave us 2 for sure. So I can use those with synthetic division because it didn't outright tell me 3 whole number solutions. So we could start off with negative 3. 1 for 7, 16, 12. Drop the 1. Well, negative 3 times 1 is negative 3. 7 plus negative 3 is 4. Negative 3 times 4 is negative 12. 16 plus negative 12 is 4. Negative 3 times 4 is 12, well, negative 12, and we get 0. Yes? Questions on this here? Then what number are we going to use next? We're going to use negative 2. Bring down the 1. Negative 2 times 1 is negative 2. 4 plus negative 2 is 2. Negative 2 times 2 is negative 4, which gives us 0, yes? Now on a cubic, getting 2 solutions is never a bad thing. because we've decreased the degree by 2. So if it was a degree 3, we decrease it by 2. We're left with a degree 1. Remainder constant x. So I just have x plus 2 equals 0, yes? At this point, this is the easiest thing we solve, isn't it? Minus 2 from both sides. X is equal to negative 2. So did the graphing calculator really give us all 3 for this one here? Well, yeah. We just had to be able to interpret that negative 2 showed up twice. Any questions on this here? Any questions on this here? I have a feeling at this point y'all feel pretty comfortable with most of these here. Yes? I mean, I know that this is your second day doing this, so that's not too bad. I mean, I think you're picking it up for the most part. But most of this here was we would graph it and then use our steps that we just did. So if we were to do this for this one here, what we'd actually get is, if you want to go back and try this, we would get that x is equal to negative 1, 1, 1, and 1 plus or minus I, the square root of 3, is what we would get for this here. This here is the last thing we're going to look at today. We're going to do at least 2 examples of these here. The complex conjugate theorem is what we're going to stop at. Tomorrow, we're going to focus purely on Descartes' rule of signs, which again is going to give us more ways to determine what the possible zeros are. And specifically, it's talking about the signs. How many positive, negative, or complex we should have. Now this here, just like with the one we had yesterday, the irrational conjugate theorem, states that if x is equal to a plus bi is a solution, it means x is equal to a minus bi has to be a solution as well. They come in pairs. Just like with radicals, or square roots, we did not have any quadratics or any higher degree polynomial that actually had a square root to begin with. So when we have our answers, they have to come in pairs, positive and negative square root. Same thing works out with our complex numbers, a plus bi. If I have a plus bi, I also have to have a minus bi. If we have one, we have to have the other. And what we did yesterday was finding the least degree polynomial with leading coefficient of 1. We're doing the same thing with this here. So write a function f of with the following zeros of the least degree with a leading coefficient of 1. And our zeros for this here are, we're saying that x is equal to 2 and x is equal to 3 plus I. We're told these 2 here are our zeros, the 2 zeros that we have. We're going to have one more. What is our other 0 going to be? X is going to equal 3 minus I. If we have x is equal to 3 plus I, we'll also have x is equal to 3 minus I. If we have one, we have to have the other. Now, just like yesterday, what we're going to do next is we're going to set each one of these here equal to 0. So the first one here, we're going to subtract 2 from both sides. And when we subtract 2 from both sides, we'll get x minus 2 is equal to 0. That's done. We only had to subtract 2 from both sides. Now, if I look at the next one, x equals 3 plus I, I'm going to subtract 3 from both sides, so these will cancel. So I have x minus 3 is equal to I. And then our next step would be to subtract I to get it officially equal to 0, everything on one side, would be x minus 3 minus I is equal to 0. Any questions on how we did this here? Now this last one here, anybody have a guess at what this is going to be? X. Yes. X minus 3 plus I equals 0. Because what did we say about the conjugates? We're just changing the sign in front of I, yes? So it works the same for this here because I is negative here. So I over here has to be positive. We're just changing the sign. Now I could still walk through this here because we would subtract 3 first, which would give us x minus 3 is equal to negative I. Then we would add I to both sides, giving us x minus 3 plus I. So if you notice that, that makes it a little bit easier because once I get one, flip the sign in front of I and I have the other. Any questions on how we got to this point here? Okay, now we multiply these together. So we're going to do x minus 2 times x minus 3 minus I times x minus 3 plus I. And again, just like yesterday, we're going to start off with the conjugates. It doesn't matter if they're complex or irrational. Those are the ones we're going to do first. So we'll still have the x minus 2. We're going to start off with this here. So we're going to do x times x, which would give us x squared. X times negative 3 would be negative 3x. And x times I will be plus xi. Then we'll move on to negative 3. Well, negative 3 times x will be negative 3x. Negative 3 times negative 3 will be plus 9. And negative 3 times I will be negative 3i. And lastly, we're going to multiply through by our negative I. So negative I times x will be negative xi. Negative I times negative 3 will be plus 3i. And negative I times I will be negative I squared. Any questions on any of this here so far? So we'll still have the x minus 2. Now looking at this here, well, the xi, positive xi, and negative xi here, these are going to cancel out. Negative 3i plus 3i, these will cancel. So if we eliminated all our I terms, do we have I left in there? We've got one of them, yes? What are we left with? I squared, yes? So we went over complex numbers. Can we leave I to a power? Well, no. I squared is what? Negative 1. Because I is the square root of negative 1, and if we square a square root, they cancel. So really what we have left here is negative 1. So I'm going to go on and combine the other terms. So we'd have x squared. Negative 3x and negative 3x would give us negative 6x. Plus 9 minus our negative 1. Well, wait a minute. A negative and negative make a positive, yes? So really I can just say this is plus 1, isn't it? So what we have is x minus 2 times x squared minus 6x plus 10. Questions on this here? Well, We have one last step. We're going to multiply these together. X times x squared would be x to the third. X times negative 6x will be negative 6x squared. And x times 10 would be plus 10x. Then we multiply through by negative 2. Well, negative 2 times x squared will be negative 2x squared. Negative 2 times negative 6x will be plus 12x. And negative 2 times positive 10 will be minus 20. Now, I write it this way just because I line everything up so it's easier to work with. So x cubed comes down because there's no common factors with it. Negative 6x squared plus negative 2x squared would be negative 8x squared. 10x plus 12x would be plus 22x minus, and we get this here. Any questions on any of this here? Any questions on anything we've done so far with this here? Does anybody find it odd that they specify least degree and leading coefficient of 1 for this here? Does that seem a little interesting why they would use that exact phrasing for these here and the ones we did yesterday? Well, let me see here. I'm going to manipulate. So 2x cubed minus did I just change the solutions? Well, what did I do from the one that we got to the one in blue? I multiplied everything by 2, yes? So if I were to solve this, our first step we could do is factor out the 2, yes? And we would get the exact same answer, wouldn't we? So I didn't change the answers by multiplying everything by 2, did I? Let's try this. So how about now? I've divided everything in half, multiplied it by 1/2, yes? But that's still not changing the solutions, is it? No. That's why they have it as the leading coefficient has to be 1. Because they set it that way. Because otherwise, couldn't I keep making an infinite number of this here? Because I can multiply the whole thing by whatever I want. And it'd be the same thing. Now, on a different note, it said least degree, right? So we had 3 to start with, yes? And those are the 3 zeros. Now say I took this here and multiplied it by x minus 2. So this here we said the solutions were 2, and then I think it was 3 minus I. We can just say plus or minus I were our solutions, yes? Well, multiplying it by x minus 2 is adding a solution of 2, yes? Well, isn't it already listed? Because the overall zeros would be 2 and 3 plus or minus I. So adding an x minus 2, does that change what solutions I have? No, I just have more solutions of 2, yes? It's still those. That's why they say least degree, because I could repeat x minus 2 or the x equals 3 plus I or 3 minus I. I can repeat them as many times as I want and still get a polynomial function with zeros of these 2 here. Does this make sense? So when they say least degree, pretty much they're saying what is the simplest polynomial function that will have these zeros? What is the simplest one we can have? That's why they put that there. So it's reducing the number of possibilities. Let's look at another one. Y'all want to look at 5, 6, or 7? Last one we do today. Let's look at 6. So here it went on and told us the zeros. It told us x is equal to 3, and x is equal to 1 plus I square root of 5. Well, the other zero is going to be x is equal to 1 minus I square root of 5. Now on these here, if you get one on the homework or test, and you notice that the radical here can simplify, and it's asking to find the polynomial of least degree with leading coefficient of 1, don't worry about simplifying it. Because what's going to happen eventually, when I multiply all these together, all the radicals will go away, yes? They'll all multiply out. So simplifying it is probably just going to make your job a little bit harder. Because multiplying just by the square root of 5 is not bad. It just shows up in multiple spots, yes? Because you could be multiplying by, instead of the square root of 8, 2 square root of 8. So now you're going to have to multiply each number by 2 plus whatever else. So leaving these as radicals for these here and not simplifying is fine. Because they'll all go away eventually. So the first thing I'm going to do for this here is I'm going to subtract 3 to get this equal to 0. So we'll have x minus 3 is equal to 0. Now the next one here, for this one here, well, we're first going to have to subtract 1 from both sides. Which would give me x minus 1 is equal to I square root of 5. And then we'd have to subtract I square root of 5 from both sides. And I get x minus 1 minus I square root of 5 is equal to 0. And what would this last one be? X minus 1 plus I square root of 5. Because it works out, we have the complex and irrational conjugate. Or if we did this by hand, we would subtract 1. Oh. Okay. Grouping, ungroup. There we go. Plus I square root of 5 on both sides. These cancel, those cancel. We get this here. Any questions on how we got to this here? Now, just because it's an I and the square root of 5 doesn't mean I need a complex, or I need a conjugate for both. I only need one. Because the positive and negative for the I and the square root of 5, that other one takes care of it. I don't need another one just for I and another one just for the square root. So at this point here, we're going to multiply these together. So we're going to multiply across, and if I multiply across, we'll get x times x would be x squared minus x plus xi square root of 5. Then we'd have negative x plus 1 minus I square root of 5. And lastly, we get negative xi square root of 5 plus I square root of 5 minus 5I squared. Because the square root of 5 times the square root of 5 would be the square root of 5 squared, because it's times itself, which would simplify to 5. Now, what did we say the square root of negative 1 is? Or square root of negative I, or, what is I squared? Sorry, what is I squared? Negative 1, yes? So it's really just going to change the sign of 5, yes? So when I do these, this is me personally, I mark I squared out and change the sign. Because it just multiplied negative 5 by negative 1. You guys can go on. I'm going to finish the video up, so if you want to see the end of this, you can. It will be posted up by the end of the day. Otherwise, we're going to finish this up tomorrow, and we will be done with chapter 4.6 and all of chapter 4. And we will be testing next week. Okay? And ACT prep is down there. So if we combine like terms, x and x would be 2x. Xi squared of 5 and negative xi squared of 5 would cancel. Negative I squared of 5 and negative squared of 5 cancel. 1 plus 5 would give us 6. And lastly, when we multiply through, we get x cubed minus 2x squared plus 6x. And then we'd have negative 3x squared plus 6x minus 18. And when we combine these like terms, if I can expand the page, the x cubed minus 5x squared plus 12x minus 18. And that would be it here.